these are the nice new tools in Rhino. This is your classic zebra. Depending on how you move the camera, you see it. But there's also now an option to lock it to the camera. We have directional X and Y. Here's another directional X and Y. This is now locked to the object. These are the variables that are exposed in the Zebra plugin, this bank right here. So the number of colors can be changed up to 10. There's 10 different colors there. They are exposed to the palettes. Let me reduce the element size so we can see all those. You can have a very small selection of colors. That makes analysis, some kinds of analysis, a little bit easier. Or you can expand it out if you just want to sort of visualize things differently. You can expand it out to a full range. There are different palettes here. Palette 2, 3, 7 different palettes currently, but there's really no limit to it. In addition, so there's the 7 palettes. Let's go back to this one. In addition, you can also change the color of the gaps in between. That's a toggle between black and white. You can toggle the size of the elements, very, very large. You can control the gap size, very small gaps between, or very large gaps between. Very large gaps, very small elements. Gives you like a graph paper look. Colors, boost up the colors, reduce the gap size, lower the element size. All of these for each different one. If you go to a different zebra visualization, here is a direct side one. That updates in this program, that updates all of these values to what seems convenient and highlights the ones that are available for that option. Different options are available for different forms of the zebra analysis. All right, so element size can be changed. Also, the rotation can be changed in this one. These rotations, there's 3 different kinds of rotation and one Y coordinate. They are the others are not available in this visualization. All right, let's turn off these pins. We're going to turn all the pins here and turn off all the pins. Let's turn off the curves as well so we can just take a look at the raw form. All right, my favorite new visualization is the dots. All right, this really gives me a nice impression of this surface. So we have sort of the stretch of the surface in 2 directions. We can look at the dots in different sizes, of course, different palettes. And that really lets us see that we have a nice slow curvature longitudinally, up and down here. But we have a very long curvature front to back on the helmet. And that's very easy to visualize here. Again, of course, all of these can be updated at the same time. So if we go back to the lateral controls, we'll turn on the laterals so you can see them. Turn on the lateral pins, which go across there. And we can kind of get a visualization of the handles of that surface. We can make the top flatter by increasing the throw. And now we see the stretch. We see the stretch and the resulting stretch in those surfaces of the curvature. So quite a bit fatter, quite a bit uglier. So we're going to bring that back in, reel that back in. We can also, of course, with this fine dial adjustment, make very microscopic adjustments in the surface. These two are tied together again with the lock button. The angles are locked at 90 degrees for now, 90 degrees across the top of the helmet. And that keeps everything nice and tangent. All right, we're going to turn off the pins there, turn off the curves. We're going to do one thing here. We're going to show how the position of this curvature along the helmet, so this is the front curvature, A. We have A lateral curvature and B lateral curvature. So B can be adjusted back further. That changes the surface as it goes along. Can be moved right to the very back. So it's just affecting that. This can be moved all the way to the front. And now the surface in the middle is kind of just under less constraints. Constraining less sort of lets the surface move on its own. but sometimes that can lead to undesirable results. At any point in time, all of the factors of this helmet, let's look at the top line. Let's increase the width. Go back to the main window here. Let's increase the width of the helmet. Width of the helmet increases, decreases, gets back to a happy medium. We can also, going to the surface menu, take these out of the equation. So one of these lines can be removed from the equation. Let's watch that. Let's watch the effect of that when that happens. We're going to remove the lateral from the rear from the equation. And now, without a lot of result, that is removed from the rear, probably because it was too far back. And that did not remove it from the equation. Let's see here. Okay, scratch that. That's something for the different form of surface. Okay. Now we have a nice curvature there. Same thing for the bottom. Let's remove the visualization of the head form. So we have the head form is underneath. The head form can be taken out of the equation. Head forms can be either A or B. They can be different coverages. And we can show the cutting surface as well. And when we're trying to, that's a testing surface. Everything above that curve, that surface in a helmet, is considered fair game for the testing labs. So that's where the thickness is maintained. All right, let's turn that off. We can look at the normal head mesh. Look at the normal head mesh here and take a look back at the visualization. Turn that back on and work around the piece there. All right, let's go back through the zebra, different forms of zebra. We have, let's go through number one, directional light. All right, that's pretty standard, locked in, variety of colors, element size, gap size, gap transparency, haven't mentioned that yet. The gaps can be flipped to transparent so you can see through and see the effects. All right, let's put the gaps back on white. Directional light, like this one a lot. Directional light X and Y gives you two different forms. The elements are not individually controllable, so they control in the X and Y directions the same amount. Directional dots we've covered. Directional camera X. Okay, this allows for that view, which is more of a classic view of distortion. So you can see some kind of rapid rates of curvature here. Okay, that's a kind of visualization. We see a little seam right here, which can be tightened up through tangency and increasing the precision of the surface. All right. Now we have directional light Y. I think there needs to be an adjustment there. There's the rotation of that, so you can look at rotation at different angles. Let's see rotation here. Lets you rotate to examine from different angles. All right, direction camera XY. This is similar to the XY from before, but tied directly to the camera. All right, this is directional dots. Again, when any one of these is selected, there's a setting that I like, so these are pre-populated to those settings. They also, the dot in the middle here indicates that it is active for that visualization. Moving this here changes the orientation of that to the camera. Beneficial in some ways. Dots can be changed size, colors increased, variety of colors, and gap size. All of these are restored. This is not currently holding the settings. When a new camera is changed and it goes back to the previous one, the default settings are then reenacted, re-engaged. All right, we have a slight discrepancy there in the surface, but overall pretty good match. This is called directional light camera Z. No rotations apply to this. None of them are highlighted. Fall off. Gap size. Gap size can be larger, and I never use the fall off because I don't find it to add to anything, but there is a fall off command as well, and that is a fading in between the colors. That fades and gives a softness to it that I just don't find to be useful. This is point light. Now this is interesting. I haven't fully explored the capabilities of this. This is a point inside the helmet that the curvature is tied to. Let me turn off the lines there. Now this can be affected by changing the Y coordinate. The point, which is now inside the helmet, can be moved outside the helmet. Once it's outside and vertical now, that point is vertically above, those curvature lines are indexing to that. That can be rotated. It can be rotated also by the dial. And as well, the element size can be reduced down to so that the bars are quite thin. This can be moved out further. Has a little bit of effect on how the curvature works, and it can be put back inside. Again, I'm still working out what this all means, but it's quite a it's an interesting form. Some more work to be done with that one. Point light camera. This is with the camera point. No rotations are in effect here. Cylindrical static. Cylindrical static is interesting. Again, haven't fully figured it out yet. It is possible to change the Y coordinate, and that doesn't seem to be doing anything, so I may be in error there. The rotation, that's sort of a Z rotation. This is the Y rotation. Let's see what affects that as we slowly turn it. Interesting, but not quite practical. There we go. Let's see. We're starting to see some effect there. Okay, something to be learned there. I don't quite know what yet. And then the rotation around the other axis. So I'm rotating around the other axis and feeding that into the module that Steve Baer built. Directional distance. This is tied again to a vertical point. Rotation can be controlled here. Y coordinate effects, and this is also highlighted. This can be controlled. This controls where that point is on the surface. Also dial box tuning. Go back to the dome view, and let's change these a little bit more mid-ratioed so we have a little bit more classic head look. Let's tip it a little bit back like skate. Okay, and we can throw the exit. We can throw the exit shorter, which will decrease above the equator line. It makes the curvature quite sharp at the equator line, or we can throw it up again. We can also change the angle. The angle can be moved backwards, moved forwards. It's maintaining tangency now with the lower bowl. And that is, let's go back to the surfaces, directional dots. We can see the effect of that here. Going concave now. All right, that should wrap it up for today. That's the different forms of surface analysis in Rhino. Give me any questions you have in the comments, and look forward to hearing your feedback.